Now, sampling process. During a sampling process, errors may arise. These errors arise at any stage of sampling. So, what are these errors? Errors which arise during sampling survey are called sampling errors. There are two types of main sampling error, biased errors. Due to selection of sampling technique, we have chosen a wrong sampling technique. Inappropriate sampling technique, bias will arise. And if size of sample is not appropriate, size is too smaller, error may arise. And there are unbiased and random sampling errors. Difference between the members of population included and not included. Remember, there is inclusion criteria and there is exclusion criteria. We must draw inclusion and exclusion criteria very carefully because error may arise during random sampling technique. And there are certain methods. By using these methods, we can reduce sampling errors. Specific problem selection. Problem selected should be specific. There should be documentation at every stage. There effective enumeration. Pre-testing or pilot study. We do pilot study or pre-testing. Methodology. There are different methodologies are used, which bias may arise. We should control our methodologies. Selection of appropriate sampling technique. Appropriate sampling technique is technique which is used according to scenario, according to situation, according to circumstances, according to our time, according to our budget, according to our research question. So by doing this, we can reduce sampling errors. And there are non-sampling errors. There are biases and mistakes in selection of sample. Errors which arise during selection of sampling technique, they are sampling errors. And errors which arise during selection of sample are non-sampling errors. And they are causes. What are various causes for non-sampling errors? Sampling operations, inadequate of response. Sometimes people don't respond. They don't understand the concept. There is lack of knowledge. Even researchers, even those who are doing the research, or those who are involved in the research, observers, they lack the knowledge. Concealment of truth. There are so many questions. There are processing errors, analytical errors. Sampling size is small. These are non-sampling errors. Now we need to calculate sample size. How sample size is calculated? Why it is calculated? Because sample size depends on number of variables. It depends on our population, size of our population, structure of our population, composition of our population. So we need to calculate sample size. Let's take an example. Total population of Pakistan is 220 million. If we want to take a sample from Pakistan, this for 10% formula, we need 22 million people in the sample. It depends on variables, number of variables. So we will do sample size calculation. What is sample? This is subpopulation or a portion of the whole. Larger the sample, more accurate will be the finding. Availability of resource sets. It required accuracy. Sample should be selected accurately. There should be optimum sample size, appropriate sample size. What is basic information? Yes, we need certain information before sample size calculation. The approach of sample size calculation can be arrived by thinking through the following set of questions. We must have answers of these questions. What type of study is this? This is observational, this is experimental, this is descriptive, this is case control, this is case report, this is cohort, this is cross section. Study type, we should know the study type. Single sample. If this is a prevalent survey, we need single sample. Comparative. If study is comparative, we need two samples, like in cross sectional or case control study. In case control study, one sample is taken from cases and other sample is taken from control. So we need a set of samples. In cohorts and study, one sample is taken from exposed and other sample is taken from non-exposed. What is the main primary outcome, or what will be the primary outcome? What you want to measure? Mean of measurement. Like you want to measure mean blood pressure, you want to measure mean cholesterol, or ordered ordinal variables. Like pain is ordinal variable. What is variability? Whether this will be experimental or not. How large difference would be considered clinically important? Which difference is clinically significant or not? We measure the significance by applying some tests like test of significance. So we must have information regarding design of study. regarding type of study, regarding study question, regarding our population, regarding clinical significance. What is sample size determination? How it is determined? Sample size determination is a mathematical estimation. We do estimation on mathematical basis, number of subjects or number of units which represent the total population. What is optimum sample size or why optimal sample size is required? There are following reasons to allow appropriate analysis. For accurate, appropriate analysis, appropriate sample size is required to provide desired level of accuracy. Our result should be accurate. We need accuracy to allow validity or significance of test. That's why we determine a sample. So we need appropriate analysis. It should have appropriate analysis, accuracy, significance. How large a sample do we need, or how much sample size is required? If the sample is too small, even a well-conducted study may fail to answer its research question because sample size is too small. Whole population are, it does not contain the characteristics of entire population like in heterogeneous population. We take a small sample size, every sub-segment or every subgroup is not included, errors may arise. It may fail to detect important effects, association. Yes, there are association, there are causation, there are effects. We will not conclude them. We can't calculate them. It may associate this effect of association imprecisely. We need precise accuracy. We need precise correlation. If sample size is too small, these type of errors may arise. Conversely, if the sample size is too large, right, they should be balanced. It should be balanced. It should not be too large. It should not be too small. The study will be difficult and costly. Yes, for too larger sample, like I mentioned, 22 million people, it take money, it will take time. Time constraints, yes. Study a certain time period and we will lose our accuracy. Hence, optimum sample size must be determined before commencement of study or before conduction of study. We should determine optimum sample size. It should not be too large, it should not be too small. What are various approaches to estimate sample size? Study design, main outcome. These are the two basic things. We must now study design, methodology of the study, and our outcome. Sample size is calculated according to a certain formula. The formula, we need certain things to apply this formula. Specific amount of confidence we wish to have, like 95%, 99%, 68%. These are various confidence intervals. Estimate the variance of population. What is variance? And we should specify the level of desired accuracy, like 90%, 99%. When we specify the above formula, then we will apply the formula. We need specific population, we need accuracy, we need confidence interval, desired level of accuracy. What is formula? Mean our proportion of interest. Then we'll apply null hypothesis. D is the range of confidence interval, 68%, 95 or 99. Two-sided percentage. So we will apply this formula. Z square our variance, our E. Z is confidence interval. Usually 95% confidence interval is taken and it is equal to standard deviation of 1.96, or we can say that 1.96 standard deviation means 95% confidence interval. Variance of population, there is variability among the population, it may vary. And E, we allow certain errors because errors are always present, so there is certain percentage of errors which is allowed. So this is the formula of sample size calculation. It is usually available in software form. So you apply a software and calculate the sample size. Example, we'll solve it by the following example. As a health officer, or a health officer wishes to estimate the mean hemoglobin level in a defined community. Preliminary information is that the mean is about 150 milligram per liter with standard deviation of 32 milligram per liter. So researcher wants to calculate mean hemoglobin. He has the information about mean hemoglobin. He has the information about standard deviation. If a sampling error is up to 5 milligram, he has information about sampling error. In the estimate, 5% error is always tolerated. That's why we take 95%. Because 5% error is neglected, is neglectable. How many subjects should be included in the study? So, what information he has? Population mean. He knows the standard deviation and then standard sampling error. He has this information. Now he will calculate standard deviation is 32. We know that we take 95% confidence interval, or we always take 95% confidence interval, which is equal to 1.96 standard deviation. So we'll multiply square of this with square of standard deviation, or we can say that square of confidence interval multiplied by square of standard deviation, and z is 1.96, and E is 5 milligram, which error which is allowed, and standard deviation is 32. So we need three things: Z, which is understandable, R, which is constant. Z value is 1.96. We need to take square of Z. Then we need to know standard deviation. We need to take square of standard deviation. Then we know that 5% error is accepted. So we take square of all these things. We multiply 1.96 our value of Z with standard deviation and divide this by error. Our sample size is 1762. So this is the easiest formula, but you have basic knowledge regarding standard deviation. You must know Z, or it is understood, and these two things are understood. E and Z, 5% error is understood, and Z 1 is equal to 1.96. But we need to calculate the standard deviation. For calculation of standard deviation, we need two things: sample size and deviation. We know the formula of standard deviation: x minus x bar square over n population. So we will calculate standard deviation, and then we will apply this formula, and we will calculate the sample size. What we have concluded: sample size determination is one of the most essential component in every research study. To conduct a research study, you want exact outcome, you want to analyze the study, you want to take accurate sample or appropriate sample, so you must need to calculate the sample size. The larger the sample size, the higher will be degree of accuracy. Yes, accuracy increases by sample size, or we can say that they are directly proportional. But this is limited by the availability of resources. Yes. For larger sample size, greater resources or larger resources are required. This is cost-taking process. Cost is required. It can be determined by using formula, ready-made tables, and computer software. Softwares are available. Ready-made tables are available. It's easy to calculate sample size, but you know standard deviation. For standard deviation, you know the population mean and total population. So basic things required are total population, mean or population mean, standard deviation, and constant are Z and E. Z is confidence interval and E is error. These are constant and these are required. By these, you can calculate the sample size. Now, we'll do an exercise regarding sampling. Which sampling technique is applied where and why? So, our first question is, we want to evaluate the teaching methodology opinion of final year MBBS students, or to evaluate the teaching methodology of final year MBBS student is to estimate it. The total number of students in final year class is 150. Total population is 150. Desired sample is 30. Right appropriate sampling technique. Right procedure for selected technique. We know that if students are 150, desired sample is 30. Appropriate sampling technique is systemic sampling, systemic random sampling. Next question is, why systemic random sampling? Because we want that from roll number 1 to 150, everyone should have equal chance, or we want to go from start till the end. That's why we'll do systemic random sampling, and we devise a gap. A gap is devised. Desired sample is 30, so gap is of 5. Gap is devised, and we will do systemic random sampling. Remember, if gap is required or we want to go from start till end, systemic random sampling is most appropriate technique. Then the next question is, what procedure? Write down the procedure. First, you will select a population, or you will select reference population from where sample should be taken. In this case, reference population is final year MBBS. Final year MBBS is reference population. Now you will apply systemic random sampling. Systemic random is applied. You will devise a gap and you will select 30 students. You will do follow up, you will make your assessment, then you will apply these results on the total population or application of results on total population. Why? Because we have taken appropriate sample from a population. Results should be generalized. You will say whether they are teaching methodology, they are happy with teaching methodology or not, or they are satisfied with teaching methodology or not. We need to know their satisfaction. So that's why we select a sample. We can't include the whole population. We selected an appropriate sampling technique, divide the gap, select 30 students from start to end. This sampling technique goes from start till the end. We applied this methodology and we will apply these results on the total class, whether they are interesting or not, they are satisfied or not. Let's do another scenario. Sampling is the process of selecting a number of subjects from all subjects in a particular group or universe. Why do we need to study the sample rather than the whole population? This is question number one. What will be the answer? Because it's almost impossible to include the whole population. Why? It will be expensive. It will be time taking. There is greater chance of errors. So, inclusion of whole population is expensive, time taking, and errors may arise. That's why we take a sample. B part. What are the uses of table of random number in sampling? Table of random numbers. Table of random numbers help in selection of sampling. Help in selection. It is easy. It is convenient. We choose appropriate sample from table of random numbers. So basic use of table of random number is selection. It makes selection easier, convenient, and you choose an appropriate technique. What is next question? For a population that is hard to reach, like injection drug users, which sampling method is appropriate? Drug users. For drug users. Part C. For drug users. This should be confidential sampling. So we need snowball sampling or non-probability sampling. Answer is snowball sampling. Why? Because this is confidential and they are hard to reach. Write a short note on stratified random sampling technique. What is stratified random technique? We discussed earlier. Stratified random. That we form subgroups. We take proportions from each group, form a strata, and do random sampling from each strata. So we can define stratified random sampling as it's a type of probability sampling in which the population is divided into subgroups. We take strata and do random sampling from each strata. So this is the answer of this scenario. We move to next question. A researcher is interested to assess writing skills of postgraduate medical training. Those who are doing FCPS training, those who are doing MPhil training, those who are doing MDMS training, and they are working in different hospitals of Lahore city. Total number of trainees is 8,000 who are working in different specialties and different years of training. If we desire to select a sample of, or if sample of 2,000 trainees is required, which sampling technique is appropriate? Why? As you have mentioned, there are different hospitals, there are different specialties, and they are in different years. In Lahore, there are multiple hospitals, there are hundreds of hospitals. There are multiple specialties. Some are working in medicine, some are working in surgery, some are doing MPhil biochemistry, some are doing MPhil public health. Some may be doing FCPS oncology, some may be doing FCPS gynecology. Some will be in first year, some will be in second year of training, third year of training, and fourth year of training. So, stratified random sampling is most appropriate sampling technique. Why? Next question arises, why stratified random sampling? Why not systemic sampling? Why not simple random sampling? Why not quota sampling? Because we can do straight of hospitals. Let's suppose there are 100 hospitals, strata can be formed. Let's suppose there are 100 specialties, strata can be formed. Let's suppose there are 5 years, strata can be formed. So we need subgroups. We can make subgroups of hospitals like subgroup of Mu Hospital, Gangaram Hospital, LGH Hospital, Gurki, LMDC. We can make subgroup of medicine, surgery, gynae, obs, peds, neurology, and we can make subgroup of years 1 till 5 for to make subgroups to for every specialty. We need, or we can say every specialty should be included. So we need strata, we need subgroups. That's why stratified random sampling technique is most appropriate in such scenario. Okay, next question. Write steps of selected sampling technique. So what will be the different steps? First, you will take population of doctors. Then, appropriate sampling technique according to our scenario, according to our study, we have decided or we have concluded that stratified random sampling is most appropriate technique. Okay, we have selected stratified random sampling. To assess writing skills, we do observation or certain intervention. We will monitor or we will do follow-up. And then different specialties are involved. We can make comparison. And then we will do assessment. After making assessment, we will apply these results. We will generalize these results. We can say that writing text skills of medical specialists are those who are doing training in medical ward are good are better than writing skills of surgical doctors, or writing skills of public health doctors are better than writing skills of gynae doctors. So we have to generalize the results. If we see the steps, first one is appropriate sampling technique, which is mandatory in our scenario. Subgroups can be made, so straight away we decided this sampling technique. We'll do intervention, then we will apply the results. Now, we'll summarize the whole session. What we have discussed? We have discussed sampling. What is sampling? Why is sampling? What is sample? We know, we have discussed that there are two major types of sampling. This is a common university question, so you must remember this. Probability sampling, non-probability sampling. Then we have discussed their subtypes like simple random, stratified random, cluster, systemic, multiphasic. We have discussed subtypes of non-probability, convenient sampling, judgmental sampling, accidental sampling, purposive sampling, snowball sampling. Application of these sampling techniques. Application is most important. First, we should know that now the application of probability sampling. We can apply probability sampling in which we can include the whole, in which the whole population has the equal chance. And in non-probability sampling, we know that whole population don't have the equal chance. Now, where simple random is applied, simple random sampling technique is applied. Usually, it is applied in cross-section studies or in applied in studies or in student researches. Where stratified random is applied, where there are subgroups, where cluster is applied, where area or families are involved, where systemic is applied, where we devise a gap, a specific gap is required, where multiphasic is required. Multiphasic is required in sampling techniques where interval, there are gaps, like in longitudinal study, there are gaps or we observe at various gaps. These are the applications of probability sampling. What are applications of non-probability sampling? Quota sampling, where proportion of population is known. Purposive sampling, where there is predetermined idea. Judgmental sampling, where a researcher judges the situation. A researcher can judge and most commonly asked snowball sampling, confidential sampling. So you must know the application call. If you know the application, then you will diagnose the scenario or select an appropriate sampling technique. Then we have discussed sampling errors, errors that may arise during sampling, errors that arise due to inappropriate sampling technique, error that may arise due to smaller sample due to too larger sample, error that may arise during sample size. These are sampling errors. They can be corrected. They can be corrected by exact knowledge, exact information, by pilot studies. Then we have discussed sample size calculation. We have discussed why sample size is calculated, why it is important to calculate the sample size, because total population can't be included in the study. We need a certain sample. We need a certain sample size. So first step is sample size calculation. Sample size is calculated on the basis of study type, on the basis of methodology, on the basis of variables. If you increase the variables, sample size increases. If you decrease the variable, sample size decreases. So for calculation of sample size, we must have knowledge regarding population mean, we know the population mean. We can calculate standard deviation. So we should know the standard deviation. Or in scenario standard deviation, population mean is given. And we know that value of z is equal to 1.96. It is understood it is constant. And error, 5% error is acceptable. So what was the formula? Z square multiplied by standard deviation square divided by E square. This is the simplest formula for calculation of sample size. You will be given population mean, you will be given Z or E, and you will be given standard deviation, and then they will ask you to calculate the sample size. Then you will calculate the sample size. After calculation of sample size, you will take the sample, and you know that sample can be homogeneous or heterogeneous. And in the end, we have solved various university questions or various common university questions, like where systemic random sampling technique is used, where stratified random sampling technique is used, what are various types of sampling, what errors may arise. So things need to remember: what is sample, what are sampling techniques, where they are applied, how we'll calculate sample size. That's all.